Distillation columns are essential equipment in the chemical and petrochemical industries, used for separating components in a mixture based on their boiling points. They play a critical role in processes like crude oil refining, alcohol production, and gas purification. 1. Parts of a distillation column. The distillation column consists of various components, each designed to perform a specific function to facilitate the separation process. Here's a breakdown of the main parts. A column shell, the cylindrical structure enclosing the internal components, designed to withstand high pressure and temperature, provides the framework for trays, packing, and other internal elements. B. Trays or plates. Purpose: to enhance vapor-liquid contact for mass transfer. Types: sieve trays, perforated plates that allow vapor to rise and contact the liquid. Bubble cap trays, caps fitted on trays that direct vapor through the liquid. Valve trays, valves open and close based on vapor flow, improving efficiency. C. Packing, found in packed columns as an alternative to trays. Provides a large surface area for vapor-liquid interaction. Types: random packing, small shapes like rashig rings or burl saddles. Structured packing, regularly arranged materials for uniform flow. D. Feed plate/section, the entry point for the feed mixture. Divides the column into two sections. Rectifying section, above the feed, enriches the lighter component. Stripping section, below the feed, removes heavier components. E. Reboiler, located at the column's base. Provides heat to vaporize the liquid, driving the separation process. Types include kettle, thermosiphon, and fired reboilers. F. Condenser, cools the vapor from the top of the column, converting it back into liquid. Types: total condenser, condenses all vapor. Partial condenser, condenses only part of the vapor, allowing lighter components to remain as vapor. G. Reflux drum, collects the condensed liquid from the condenser. Splits the liquid. A portion is returned to the column as reflux, and the rest is collected as distillate. H. Instrumentation and control systems. Pressure gauges, monitor internal pressure. Thermometers/thermocouples, measure temperature at different points. Level indicators, ensure proper liquid levels in the reboiler and reflux drum. Control valves, adjust reflux ratio, feed rate, and heat input. 2. Working principles of a distillation column. The working of a distillation column is based on mass transfer and thermodynamic equilibrium. Here's how it operates. A. Principle of separation. Components in the feed mixture are separated based on differences in boiling points. Lighter, more volatile components vaporize and rise, while heavier, less volatile components condense and flow downward. B. Vapor-liquid equilibrium, VLE. At each tray or packing level, vapor and liquid phases achieve partial equilibrium. The composition of the vapor and liquid changes progressively, leading to separation. C. Countercurrent flow. Liquid flows downward due to gravity, while vapor rises due to the heat provided by the reboiler. This countercurrent flow enhances the contact between phases, improving separation efficiency. D. Reflux. A portion of the condensed liquid from the top is returned to the column as reflux. Reflux improves separation by enriching the lighter component in the rectifying section. E. Stages of separation. Each tray or packing layer represents a theoretical stage where a specific level of separation occurs. More stages or trays result in higher separation efficiency. 3. Working conditions of a distillation column. The efficiency and operation of a distillation column depend on maintaining appropriate working conditions. A temperature. The column operates at temperatures corresponding to the boiling points of the feed components. Temperature is controlled to avoid thermal degradation of sensitive materials. B. Pressure. Atmospheric distillation. Operates at atmospheric pressure for general applications like crude oil refining. Vacuum distillation. Reduces pressure to lower boiling points, used for heat-sensitive components. High-pressure distillation. Increases pressure to handle gases or high boiling point mixtures. C. Feed composition. The feed's volatility determines the ease of separation. Multi-component mixtures may require precise control of feed location and flow rate. D. Reflux ratio. The ratio of reflux, return liquid, to distillate, collected product. A higher reflux ratio improves purity but increases energy consumption. E. Energy input. The reboiler must provide sufficient heat to vaporize the liquid while maintaining efficiency. Overheating can lead to thermal degradation, while insufficient heat results in poor separation. F. Safety considerations. Columns handle flammable and volatile compounds, requiring robust safety measures. Overpressure relief systems, flame arresters, and temperature alarms are critical. Applications of distillation columns. Oil refining. Fractional distillation of crude oil into gasoline, diesel, kerosene, etc. Chemical production. Separation of reactants and products in chemical synthesis. Alcohol distillation. Producing spirits like whiskey and vodka. Gas separation. Producing industrial gases like oxygen, nitrogen, and argon. Thus, distillation columns are vital for the separation of chemical mixtures. By understanding their parts, principles, and working conditions, engineers can optimize their design and operation for various industrial applications. A well-designed column ensures efficient separation, energy savings, and safe operation, making it an indispensable tool in chemical engineering.